Now, with that, I did mention this is going to be kind of a short and sweet EcoCast. We've got just two presenting teams here. It's going to fly by. It's going to be jam-packed with valuable information, as always. So let's dive into it. Today, we have the Scale Computing team coming out of the gates. The team is going to kick off our EcoCast, and I've got Chris Nietzold, the Senior Hardware Engineer at Scale, who's going to be chatting with us. And after that, I'm going to join Chris for the Q&A. So, Chris, are you ready to take things away?
I sure am.
Awesome. Go ahead.
Excellent. Thank you very much. So yeah, my name is Chris Nietzold. I work in the product team in a role of senior hardware engineer, and I manage all of our appliances and all of the integration on that side of things. So taming the storage chaos, we know that cloud computing, it significantly accelerated our ability to support digital business, provided better availability and scalability without the burden of managing IT infrastructure. But as we know, not all applications or really data should be stored or run in the cloud. There are situations where it may not make sense. Why not put everything in the cloud? Well, the things that we hear from people that we engage with are, number one, cost, not just the cost of the cloud storage, but also keeping those costs predictable. And that's really because of just data explosion. Things like video surveillance or sensors out at the edge that can have kind of a lumpy ingress of the amount of storage that is going to be eventually needing to be stored. Another one is latency. There's a lot of applications, especially newer applications, that are requiring more real-time response. And so, ensuring that the data can be stored quickly and also retrieved and accessed quickly, so for analysis or for really supporting the application, is critical. Another is resiliency. And normally you would think of cloud storage as being quite resilient, but what if you are in a situation where you don't have a network connection? Think, for example, shipping freighters that are crossing the ocean. Starlink has made a lot of inroads in making data accessibility a lot better, but there's still scenarios where where having the data on premises is really important. And then, of course, regulation. There's myriad regulation out there as far as what we can do with PII, where user data can be stored, and what data is considered critical and not. Navigating that can be a little bit tricky. Making sure that the data is local gives you complete control over that. So I mentioned the edge, and the word gets kicked around quite a bit. But really, it's important. What is the edge? It's all the locations where mission critical applications are run, close to or even outside of the data center. And Gartner reports that by 2025, 75% of all data will be generated and processed at the edge. And we're really seeing that pick up quite a bit. Needless to say, we see this as a growth opportunity. Moving on. So, with the need for on-prem storage, in addition to the cloud, that's clear. We need to have both of those elements. And while the needs are well understood, the choice of infrastructure solution is critical, really due to the unique challenges that are posed by managing both on-prem and cloud storage. It can get quite complex. So when we do have a larger storage footprint, it's critical that the solution that's deployed on-prem can provide availability. And it has to be simple, and it has to be efficient, but it also has to be flexible because, again, we don't know what that data is always going to look like. So Scale Computing Platform, it combines everything that you need kind of under one umbrella. You have the actual underlying Scale Computing Hypercore software, and that covers your virtualization, the interaction with the actual hardware and the servers, the storage, the backup and disaster recovery, and a very powerful fleet management tool that we call Scale Computing Fleet Manager, and that delivers a single manageable solution for enterprise edge customers, MSPs, and the like. So HyperCore, it's really the software that runs on premises. It's the entire HCI stack. It's very easy to deploy. In fact, it can be deployed in an automated fashion such that you set up the deployment even before the hardware arrives on site. It's fully integrated, and the virtualization solution provides high availability. Now, Fleet Manager, on the other hand, it makes monitoring of the health and status of all of the systems that you might have out in the field extremely easy. It's cloud-based, centrally managed for all deployments, and it can manage any number of clusters. You have proactive alerting. You can highlight areas that need attention from a dashboard. Everything is right there letting you know if you have something that's not performing up to par or has some condition that needs to be addressed, or if everything is operating smoothly, that's also fed back to you. You've also got the ability to drill down to the cluster level, to the node level, and even to the VM level, and even jump directly into those VMs right from that cloud interface. So at the core of the storage portion of Scale Computing Platform is Scribe, and that's our Scale Computing Reliable Independent Block Engine. This was developed because at the time there was really nothing that fit the bill. We had used several off-the-shelf solutions and attempted to adapt them to what we needed, but nothing really fit the bill. And really, it came down to the footprint as far as resources are concerned, the reliability, the atomic nature of making sure that the data is confirmed from one end to the other. This is a block engine-based engine. And like I said, very minimal overhead, extremely stable, and it also bypasses the entire normal storage stack that you would find within an operating system and speaks directly to drives. Paired with that, we have our AIM functionality. This is the Autonomous Infrastructure Management Engine, and this is really the think of it as the watchdog for the system. So it takes a bunch of data points from all of our collectors. Those collectors get fed into these checked values that are looking for the status of each of those collector elements. And from there, things are business as usual, or they can raise conditions. And once a condition is raised, it goes through a series of logic choices and actions to either self-remediate that issue, or if it's an issue that requires attention, it's going to raise that up and make sure that that's visible and it can be actioned immediately. In addition to that, of course, we have built-in data protection, starting with the VM level snapshots. Additionally, you have cloning, so you can have a template of a specific workload, or you can spin off a new workload, a new variant, for example. And then, of course, replication to either a secondary target or an offsite target. And that includes full VM recovery and then entire workload groups, if necessary. So really what we're looking to do is just move that beyond, get the data beyond the traditional IT silos and have something that is as easy to manage as you would with cloud storage, but with a lot more insight into what's going on under the scenes. Really, you have a single unified redundant system, and it's everything is redundant. The storage is distributed among all of the nodes. There's no single node, single drive, etc. that's in the entire setup that would have only one copy of that data. So the data is distributed such that really hardware becomes a secondary concern. And then comparing to some of the more traditional options that are out there, VSA, for example, really we use a fraction of the resources. And so we make sure that the resources that you're putting out on premises, those resources are used to run your workloads rather than just running the storage subsystem. For each of the individual hardware nodes in a cluster, our starting point is under 4 gigabytes for the entire hypervisor and the storage layer management. And so really, in summary, with Scale Computing Platform, you have an extremely resilient system. It's extremely easy to set up and manage, and it also scales, as the name would imply, by just adding more storage and compute resources as needed. In addition to that, you can also mix and match nodes. We put a lot of effort into making sure that at the virtualization layer, we maintain compatibility regardless of which direction you're going. So even jumping between classes of CPUs, you won't run into a scenario where you have an incompatibility that might impact live migration, for example. And with that, I think I can open it up to questions.
Right. Sounds awesome. Thank you so much. Great presentation. We actually have quite a lot of questions, so let's see how many we can get through here together. I do want to quickly just mention to everyone in the audience, I'm going to throw up a poll here for you. So this is essentially just asking what additional information you might be interested in from Scale Computing. So data sheets, white papers, personal demo, pricing details, plunk in your answer. This is your wish list, your easy button. And after the EcoCast, the Scale team will get everything to you that you're looking for. Now that said, let's dive into it then. All right, Chris, you ready? You ready?
I sure am.
Okay, so first question I've got here is what specific AI ops capabilities should IT professionals look for to improve efficiency and performance?
So great question, and it's actually in answering it, it's a bit of a misnomer. If you do have AI ops, the name of the game is that it's going to be self-managed. Really, there should be some level of intelligence, but under the hood, when we're looking for kind of attributes of what that means, from a storage perspective, block device error tracking extremely important. That predictive analysis of any of the hardware. If we're seeing something coming up over the horizon or we're reaching end of service life or any other anomaly, we want to be able to react to that quickly. That's also going to include host environmental stats, simple things, speeds and feeds, your temperatures, your I/O rates, that sort of thing. And also the clustered communication and network latency. Oftentimes the latency anomaly could sneak up on you, or that's some building up a bit of a protracted SLA over time, and you want to make sure to stay on top of that. And then, of course, managing the data access patterns. That kind of leads into the tiered storage architecture a bit, but really those data access patterns, if you really do have some hot regions, that's something that the system should be identifying and reacting to.
Incredible. Okay, thank you. Next question here is from Elizabeth. She's asking, are there any orchestration tools included with Scale Computing?
Yeah, so we kind of touched on the Fleet Manager. That Fleet Manager web interface that really gives you quite a bit of tools for things like deploying updates, for managing the status of all of the clusters out in the field. In addition to that, of course, we have our REST API, which can support any number of orchestration or automation activities that you want to perform. And then on top of that, Ansible. We have a full Ansible collection and playbook that you can use to deploy anything from the cluster configuration down to individual workloads, storage targets, everything else.
Excellent. Thank you. Okay, next one I'm going to throw at you here is what are the most critical techniques for proactive capacity planning in storage infrastructures?
That's a good one. So I think from my perspective, understanding kind of your growth metrics and your data trends, that one can be one of the trickiest, but getting some insight there, and especially over time, that can help with some proactive capacity planning. Also, is using an inherently scalable design. We use that from a cloud perspective. Of course, that's basically infinitely scalable as long as you have the wallet to support it. But making sure that you're using a scalable design so that if and when it's time to start putting out additional runway, you've got it. Performance metrics, of course, to triage your data inflows and making sure that you're keeping up with that. And that might require, again, scaling out a bit. And then also tiering to optimize the utilization and performance. Deduplication is critical. And then, of course, disaster recovery, because the capacity planning from just a rote perspective, that's fine. If you end up losing everything or can't recover, that's going to change your strategy quite a bit in an unpredictable way.
Okay, excellent. Well, we're going to talk a lot about storage, but to continue on storage and scaling, Michael is asking, does scale support containers and or Kubernetes?
We do, yeah. We right now we're working on an initiative that will make using containers and specifically Kubernetes much easier and more of a turnkey experience. But of course, we would support running containers atop a host VM.
Perfect. All right. So lots in the works, lots of evolution. We still have a good chunk of time here, so I'm going to just keep these rolling if that's okay with you.
That'd be great.
Perfect. Okay. Next one is, could you explain how automated tiering and data deduplication work together to optimize storage performance and efficiency?
Yeah, definitely. So, as far as the initial tiering, you have kind of your fast layer, and then you've got your slower layer. That fast layer is going to ensure that you're handling data inflows and making sure that they get to the fastest possible storage layer immediately. And then from there, you have your deduplication to make sure that you're just minimizing your footprint, and that's happening again at that top layer initially where possible, and then longer term, you really have that data locality policy to make sure that you're using the storage most efficiency. So there's that kind of first filter that comes in and says, can we do some deduplication here? But then over time, as that data gets down tiered into kind of a colder storage layer, we're continuously going through and identifying any blocks or any fragments that can be deduplicated from there.
Excellent. Excellent. When I pitched you the question, I was like, I don't know if I've seen deduplicated written very often. Like maybe you see that all the time, but I was like, deduplication. Okay. Okay, next question here is from Steve. He's asking, do you need to convert your VM format to AWS for export or import?
As far as format conversion, there is some format conversion that happens under the hood, but as far as getting um, uh, you know getting VM data onto the scale computing platform, for example, you have a number of avenues to do that. We have, of course, an interface where you can pull in from a network share. You can also do a direct upload of just what we call virtual media import, where you can just click and drag and throw it into the interface. It can also be thrown in through the API, can also be sent up via Ansible. All of these techniques, though, once the VM format comes in, we support a wide variety of formats, all of your VMDKs, VHD, VHDX, etc. And behind the scenes, without you having to get your hands dirty, that's going to be converted into a format that'll operate on platform. And if you need to move that data out to, say, a cloud storage provider, we use a standard QCOW2 format that should be fairly portable.
Yeah, excellent. Easy, easy. Okay, this is a bigger question here. Michael's asking, considering that much or most of the data is moving, will be processed at the edge, does it mean that each edge appliance will need the same tools or software that are, well, this is a wordy one, that are or have been used to process at the main central core servers? Does that mean more expense or on redundant software than, let's say they're budgeting for currently?
Sure, I think that one is going to come down to a bit of architecting and preference. We see all manner of different verticals that are operating using scale computing platform. Many of them will use individualized tool or bespoke tools at the edge that really serve a different function than the ones back at the kind of main cloud data stores, and because they're doing different work on that ingress. It's often the case that most of that data as it comes in isn't going to be needing to be stored, but some insights about it may need to be. So perhaps that comes in, some analytics are run, we get that final data that we really want to store and add to the collection, that gets sent off to the cloud, for example. And in that case, we wouldn't be using those same tools in the cloud. So there wouldn't be a duplication of effort there. But that's really going to depend on really each individual workload or approach.
Gotcha, gotcha. Okay, excellent. Okay, a few more here. Next one is, what specific benefits does Scribe offer in terms of data accessibility, security, and overall storage efficiency?
Excellent question. So first off, and this was one that we had a hard time with, again, with the earlier incarnations before Scribe existed, but atomic validated operations. We did not want to have to rely on, for example, battery backups or any kind of power loss protection to ensure that data was going to make it where it was going to make it. We have a system that ensures that that second copy is written and validated before anything moves on, and we consider it a completed write. There's also no after the fact consistency scrubbing. The way that the metadata layer works, as soon as that data is written, we can validate it, and it's constantly monitored so that we know that the data is there and it has the integrity that it needs. Then also the data locality management. As far as the multiple copies, we keep there's essentially a map. It's not really an index, but it's a map that shows where that data locality is. If there's ever a scenario where we run out of that kind of replication factor one or replication factor two, the system will automatically repatriate the data so that we maintain that. And then finally, that automated repatriation in the event of a hardware failure or in the event of reducing the size of an actual on-premises installation. There are situations where we've seen people bring down the size of a cluster because maybe they overestimated, or technology has just gotten better so they can consolidate a bit.
Okay, excellent. Thank you for that. Great answer. Okay, I think I'm going to have time for two more questions. This has been great. I'm loving this. I get to really pick your brain. This one is about error or data recovery. So essentially just asking, what's the error or data recovery process if and when something happens?
Sure, I guess it would depend on what the scenario is. So our MO with Scribe especially is that any number of devices within a cluster, they can go down, and we have that covered. So in the event, for example, a drive goes down, it's just kind of a common occurrence that can happen. That data is immediately seen as not having that second copy. We immediately establish that second copy. If an entire node goes down, it's kind of the same thing. We just look at that slice and we say what data is missing, and we rebuild that. Now, in the event that you have, say, a double or triple fault, that we keep, as long as we have one copy of the data somewhere, if it can't be replicated at that point, we're going to lock things, raise a condition through the AIM automated responses that are going to say you are in a data redundancy degraded situation. This needs to be resolved immediately, and that might mean replacing a piece of hardware, might mean switching over to replication target or a backup. But we're going to make sure that there's a level of awareness immediately, and that there's no action that's going to be taken that puts you into a further precarious situation.
Beautiful. And I assume that's all happening kind of, automatically through the software, and then someone's just going to get a notification. They're like, oh, this is missing, this is gone. If it gets to
Correct.
that
Yeah.
heightened point.
Yeah, and once that condition comes up, that's really, hey, we've done what we can do. We're going to need a little bit of assistance from the scale support team, or at least just the end user to let us know that, hey, this is occurring.
Okay. Truly, my last question for you here is so Suresh is asking essentially, what are limitations of an on-prem cloud solution? Okay, hold on. My poor punctuation here. But I guess he's kind of asking limitations for on-prem versus cloud solutions. Can you maybe give like your hottest answer of where you would go based on your mix of on-prem and what those limitations would be?
Yeah, I mean the standout one is that in a cloud scenario, if you have the budget to handle it, you do have effectively unlimited resources. Managing that can be a bit of a challenge, but when you're on-prem, you do have a specific amount of resources. If you need to expand that, some action needs to be taken besides just clicking expand my subscription button. So that is very real, and it's something that where a lot of proactive planning can save you time and make sure that things just kind of roll out smoothly as that data and the demand for compute grows.
Awesome. Thank you. So, true final question is, where should people go if they're interested? What's that, call to action or best next step if they want to check out Scale and give it a go?
Yeah, I would say, scalecomputing.com. We have a lot of resources on there, a lot of testimonials, a lot of background information, white papers, information that you can get. And of course, you can always reach out to us, anybody on our sales and marketing team. We're happy to answer questions and just talk about the product and about your specific workload needs.
Amazing. Beautiful. Well, thank you for being here. Thank you for supplying so much information, letting us pick your brain so diversely, and I can't wait to have you back in the future.
Awesome. I enjoyed it. Thank you.
A pleasure. Take care.